people will ask, how much more boost will the turbo upgrade give them? And so I want to run this topic by you and explain everything. So the way that it works, the turbo upgrade does not increase the boost pressure, but it is a possibility that it can if you have a non-wastegated turbo. So in this video, I'm going to give you a further explanation of that topic. This is an HX35 turbo. These, depending on application, can be good for 400 to 500 horsepower, depending what you put it on. Some of the people with the gas motors are able to get around 500 out of them. The main topic that I want to mention here is some turbine housings are wastegated and some are not. If you don't know what a wastegate is, the purpose of the wastegate is you got this little lever here. This will relieve the pressure that's in the exhaust before it reaches the turbine wheel, and the purpose of that is to regulate the boost pressure. So in housings that do not have this valve, the way that the pressure is regulated is it's just by the size of the turbine housing. Here's two examples of turbine housings that do not have wastegates, and there was no wastegate on the trucks that they came off at all. See, sometimes you'll have a wastegate in the housing, but then sometimes you'll have it off the manifold, but that's usually an aftermarket setup. In this case, these trucks were designed to not have a wastegate on these early models. Now, the way that they limited how much boost that they would press into the vehicle or into the motor is by the size of the compressor wheel. So they would take the compressor wheel. If they had a turbine housing that was not wastegated, they would usually use a very small or undersized compressor wheel so that it wouldn't boost more than they wanted it to. Here's two different size compressor wheels. The back one is a 62 and the front one is a 67. One will flow more at 44 psi than the other, which is going to be the larger one. When you increase the size of the compressor wheel and you have a wastegated turbine housing, or if you have a 6.7 Cummins that has the VGT vane, the VGT vane on those trucks is designed and used by the engine's management system, which is the ECU or ECM or PCM, depending on the term that the manufacturer calls the control unit for the engine controls. It's regulated by that to control the boost with the VGT vane. On this model, you have wastegate, so it's completely different, but it's using the same purpose. It's there to control the boost. So if you have a 6.7 Cummins and you go to put either one of these compressor wheels on there, the boost pressure is going to be the same, but you will see an increase in horsepower because the amount of airflow is changed by the size of the compressor wheel that you put on it. Because each of these wheels flow, well, the larger the wheel will flow more airflow per psi than the smaller compressor wheel. Now, if you go to have a non-wastegated turbine housing but use a larger compressor wheel, then it's a possibility you could see more boost, but it's still regulated by the size of this housing and by the size of the compressor wheel. So if you use that larger compressor wheel, then yeah, you could see more boost. And no, I don't have an answer how much you would see or how much boost you would see, because I don't own every single vehicle that I rebuild the turbos on. So I don't have an answer for that. But yeah, it probably will increase the boost if you go with a larger compressor wheel with a housing that has no wastegate on it. But how much, I don't know. And also you have to consider that you could see more boost with this turbine housing under different circumstances. And what I mean by that is if it's really hot and your EGTs are hotter than normal, you will see more boost in those conditions because the pressure inside the turbine housing will be increased with heat. which will cause this wheel to spin faster, which will cause the other side of the wheel, which it's connected to press more, or to rotate at higher RPM, which will press more air into the engine. The main thing that I want to get across here is, I think people will wonder, okay, so why would I want to do a turbo upgrade if it doesn't increase boost? Well, the reason is because it increases horsepower capability. Now, like 30 pounds of boost on this HX35, you may make 350 horsepower. But if you do 30 pounds of boost on the 62 compressor or the 67 millimeter, you have the capability to make a substantial amount of more horsepower than the stock turbo. The turbo upgrades that we do on these models usually have the capability to increase up to 400 horsepower or more, depending on what you're putting it on and depending on the size of the turbine housing used, because the restrictive point in the turbo is the size of the turbine housing. If you go with a much larger turbine housing, you can move much more air, which gives you much more horsepower capability. So now I'm going to explain how you control the boost. On the newer trucks, usually it's done electronically. This is an electronic solenoid, and the computer that controls the vehicle's engine management system will control this. So you can use a tuner to increase the boost on this model. This is a HE351CW. Same thing with the 6.7 Cummins. You can adjust the boost with the tuner or the tune. So if you upload a tune, usually it's already set based on which tune you upload. Now with one that does not have the electronic control valve or solenoid, you can use what we call a boost controller or a boost fooler. It's basically putting a one-way or adjustable valve or adjustable spring in between this line and the wastegate actuator. See, this usually has about a 30 or 35 psi spring in it. So if you just left no regulation in between this, then this will open at 30 or 35 psi depending on what size spring is in this. So if you just want to run 30 pounds, it would just be this connected to here with no regulation there. And so, you know, the way this one is, this air will not go past this thing until this opens. So that's what controls the boost on the electronic models like this one. If you use the boost controller, you have an adjustable spring in between the two, so it blocks off the pressure until the spring is opened on the boost controller, which you set. So you can basically set the spring to 44 psi or whatever you plan to run, and then as soon as it hits that boost level, then the spring of the electronic or the boost controller will open, and the airflow can now go from this through the boost controller to the wastegate to regulate the pressure in the turbine housing.